Master Python Itertools for efficient data handling by learning how to leverage Python's Itertools for advanced data manipulation, optimizing data processing tasks, and making your code more efficient and readable. Welcome to our channel. Did you know that Python's Itertools can drastically improve your data handling efficiency? In today's video, we'll dive deep into how you can master Itertools for advanced data manipulation. We'll explore iterators, iterables, and practical implementations that will make your code both efficient and readable. Whether you're working with large datasets or just want to optimize your loops, this video has you covered. Stay tuned to learn how to implement Itertools in various practical scenarios and enhance your Python skills.
Before we dive into Itertools, it's important to understand the concepts of iterators and iterables. In Python, an iterable is anything you can loop over, like lists, tuples, or strings. Think of an iterable as a collection of items. An iterator, on the other hand, is an object that helps you traverse through those items one by one. You can convert an iterable to an iterator using the iter function. This is crucial for efficient data handling because it allows you to process items one at a time without loading everything into memory. As we explore Itertools, keep in mind how these fundamental concepts come into play.
The Itertools module provides several powerful tools, including count, cycle, and repeat. These are infinite iterators that can be incredibly useful for generating data patterns. The count function generates an infinite sequence of numbers, useful for indexing or creating a sequence. Cycle takes an iterable and repeats it indefinitely, perfect for looping through options continuously. Repeat will repeat a single element a specified number of times or indefinitely if no count is given. By understanding and using these functions, you can handle repetitive tasks efficiently in your data processing tasks.
When working with multiple datasets, combining them efficiently can save both time and resources. Itertools offers chain, which allows you to link multiple iterables together seamlessly. This is much more efficient than manually concatenating lists or other data structures. The product function, on the other hand, helps you compute the Cartesian product of input iterables, a common requirement in data analysis to explore all possible combinations. By leveraging these tools, you can manage complex datasets with ease, ensuring your code remains clean and performance optimized. Filtering data is a common task in data processing, and Itertools provides efficient ways to do this with Compress and Filterfalse. Compress allows you to filter an iterable based on a selector iterable, effectively selecting elements that correspond to true values in the selector. Filterfalse, on the other hand, is the opposite of Python's built-in filter function. It filters out elements that return true for a specified function. These methods are more efficient than traditional list comprehensions or looping constructs, especially when dealing with large datasets. Understanding their use can significantly enhance your data manipulation capabilities.
Data grouping is essential for analysis, and Itertools' Groupby function is a powerful tool in this regard. Similar to SQL's group by clause, Groupby allows you to group data based on a specified key function. This can be particularly useful when dealing with large datasets where manual grouping would be cumbersome. By grouping data efficiently, you can perform operations like sum, average, or count on grouped data, making your code more efficient and your analysis more insightful. We'll explore practical scenarios where Groupby can be utilized to streamline your data handling tasks.
Islice and Starmap are two Itertools functions that can significantly enhance performance in Python data handling. Islice works like the traditional Python slicing but is designed for iterators, allowing you to efficiently slice without converting to a list. Starmap applies a function to the elements of an iterable, similar to the built-in map function, but it is more powerful when dealing with functions that take multiple arguments. By using these tools, you can handle large datasets more efficiently, avoiding unnecessary memory use. We'll explore examples and best practices for integrating these functions into your workflow. To truly master Itertools, it's important to see how it can be applied in real-world scenarios. From data analysis to automation scripts, Itertools functions can significantly streamline your processes. We'll dive into practical examples and case studies that demonstrate how Itertools can be used to handle complex data tasks efficiently. By integrating these powerful tools into your projects, you can improve both efficiency and code readability, allowing you to tackle advanced scenarios with confidence. Discover how professionals use Itertools to revolutionize their data handling tasks. Thank you for joining us on this journey to master Python's Itertools. We've covered a range of functions from count to starmap, each offering unique ways to optimize your data handling tasks. Remember, efficient data manipulation is key to enhancing your coding skills and tackling larger projects with ease. We encourage you to practice these concepts and integrate them into your projects. Don't forget to comment below with your thoughts, share this video with others, and subscribe for more insightful content. Let us know what topics you'd like us to cover next.